Only mode.
So, hello everyone and welcome to this week's webinar. This week we're joined by Todd, who's going to be teaching us some of the built-in logical functions Excel has to offer. Todd is very experienced in using Excel and knows his way around Excel better than most people. So hopefully you should learn a lot in today's live class. So I'm just going to hand over to Todd now. If you've got any questions, just pop them in the question box and we'll get to them whenever Todd can. So yeah, over to you, Todd.
All right, very good. Thank you, Sydney. Can you guys hear me just one more time? I just want to make sure. Are we good, Sydney?
Yeah.
Okay, very good. Hi, everybody. Thanks for that, Sydney. It's a very, very gracious introduction. So yeah, today we are going to be talking about logical functions in Excel. That's what what the guys asked me to cover. And logical functions are actually very simple for the most part, but extremely powerful, and they're kind of just built off of the idea that you test some argument for whether it's true or false, and we'll get to that here. So let me just kind of cover some of the objectives I had in mind for today, and hopefully we'll get to all of them. So first thing, we'll kind of cover what is a logical function, and then we'll get to the if function, which is probably the most notable logical function. It's probably the simplest logical function, and then there are others like the and function, the or function, and these can be very powerful, and that's why I've included those. There'll be some other logical functions we don't actually get to, but I'm trying to highlight some of those that I've used most in my career and in my work that I find are most powerful. And so the and or function are included in this discussion, and those can be used actually on their own, but for the most part they're very powerful when used together with the if function, and we'll see some examples of that. And then we'll kind of cover the if error, because that's one that I use quite a bit. And it can just be very helpful for helping you kind of keep your spreadsheets, what I would call clean. It's just kind of a housekeeping thing. So sometimes you might have some errors that are involved in maybe calculations that are just unavoidable. They're just kind of a part of what you're doing. And this is a good logical function that will help you use that or leverage that to your advantage. So we'll also look at the sum if function. It's one of these functions that's built on the if idea. And then if we get a chance, we'll look at the sum ifs. Now these ifs functions are actually new for users of Office 365 or Excel 2016, and they're built off the older built-in functions like the sum if, the count if, and then as you can see down at the bottom, there's the new ifs function. So what that basically is just an expansion of the older functions, and we'll get to that later on in the hour. We'll look at nested if functions, and we'll look at the benefits versus the limitations. It can be a very powerful thing, and I've used them for years, but with the new ifs function, it actually takes that concept and builds on it and makes things a little bit more efficient. So let's move on. So what is a logical function? So it's basically a function that tests an argument for validity. And they can, the logical test can include and involve literal values like literal strings, numbers within the formula. They're typically comparisons among values, and they can include equations and calculations. You can use cell references, so values from other cell references, as well as formulas. So the test can have only one of two possible outcomes. It's a what would be considered a Boolean value outcome. So it can either be true or false. And so that's what it's built on. And it's simple enough. If you wanted to test something, and we'll see here in a little bit with some examples, say you wanted to test, does the number one, or is the number one greater than 0? Well, of course we know it is, so that would be a true outcome. Well, what if you wanted to compare, is 0 greater than 1? Well, of course you know that's not true, so it would be a false outcome. So at that level, it's pretty simple. But what's so powerful about these functions is you can actually replace those true and false outcomes with other values, even other equations or calculations. So they can be strings, numbers, other cell references, and then of course they can be formulas. And then you can actually use other logical functions within those true or false outcomes to expand your formulas as the complexity of your task calls for it. So let's go on to the next slide here real quick. So one of the things that you really need to get a grasp on before we get into the logical tests, that they're typically comparisons. So you need to know your comparison operators. So you know the equal sign, greater than, the less than, there's less than or equal, greater than or equal, and then to use both the less than and greater than together in sequence gives you a not equals comparison. So over here on the right side of the slide, you can see some of those in context. 2 greater than 0, does 3 equal 3, cell reference, B2 not equal to blank. So blank is going to be a double quote with nothing in between it. And that'll actually be something we'll cover. We'll actually do a couple of examples where we use the blank. And then just other examples here where you've got calculations between cell references. Does that, is that less than or equal to some literal number value? Does it equal some literal string like y? And even calculations that, not just addition, but multiplication. And then, of course, any other comparisons with string values or even another function. So let's look at the if function. So the syntax is, as you can see here on the screen, it's 3 arguments. It's basically if your logical test is your first argument, and that's what you're testing for validity. Your second argument is the value if that logical test turns out to be true. The third argument is the value if that logical test turns out to be false. Now the square brackets around the second and third arguments just indicate they're optional arguments. Now that doesn't mean they're both optional all the time. What that does mean is that if you place one value in for, say, the second argument, you can omit the third argument, and then if it turns out to be true for that third argument, it'll just return a 1, or, well, whether it's true or false, it'll return a 1 or a 0. That may be confusing to you. We'll kind of steer clear of that. I'll show you one example of how to do that, but I typically use all 3 arguments just to keep things clear. And if you wanted a translation to kind of make this clearer, I've tried to do that here. So basically saying if this is true, your logical test, the next argument is do this. Otherwise, do something else. And I hope that makes sense. So let's take a look at some examples. Let's get into the Excel part of this now that we've taken a look at some slides. So here's the if function, and here's, again, a view of your syntax for the formula. So let's look at, for instance, we have if 1 is greater than 0, I've just placed in true or false for those arguments. Now in this case, these aren't actual string values, they're actually Boolean values, true or false. Now I could put string values in here in between double quotes and it would give me the same results. But just know that in these logical functions, this true and false are actual true and false in the Boolean sense, whether like you could even put in a 1 or a 0, 1 for true, 1 for false. So we know that 1 is greater than 0, so of course it evaluates to true. And over here I've shown, tried to show what formulas are in these spaces. Excuse me. You can see the result here. And so in these first 4 examples, I've just used literal values hard-coded into the formulas. So we know that 1 is not equal to 0, so that evaluates to false. And then in this case, we know that what we've got here is a comparison of a string value because it's in double quotes versus a number value. And while in context, or I guess in I don't know, in reality, you would look at this and say, well, that's a 1 versus a 1. But from an Excel standpoint, anything in double quotes is a string, so it's going to evaluate this to actually be false. And so another example here where we have literal values as our logical test, we're asking if 91 is greater than 70, we would want to return the string value pass if that's true. We've replaced that in as our true or our value of true argument. And then the string value fail is now substituted in for the value of false. And so we know that 91 is greater than 70 in this case, so we're going to return the value of pass. So I hope you guys have kind of started to see how that works. We've moved on from actual true and false values to actually substituting in the values of whether it's true or false. And so in this case, we're going to move on to looking at evaluating using cell references. So we're going to evaluate whether C15 here is blank. So it's if C15 equals, again, it's that double quotes with nothing in between, that stands for a blank. So we want to return the value blank, a string value blank, if it does evaluate to true, and a string value not blank if it evaluates to false. So of course, it evaluates to blank because there's nothing there. But if I were to put something in that, it will now evaluate. Well, that's not right. Hold on, guys. I've got it evaluating the wrong cell. Sorry about that. So let's scoot that down there. And now it says not blank. So again, if I demonstrate and I delete that value, you can see how the formula now changes the value to blank. And so in this case, we've got if C17 equals hello, we want to return the value hi if it's true, the value howdy if it's false. So we see that that value is hello, but if we were to change that to hi, now that's going to change our value to false or howdy for false. So next, we've got some evaluations here that involve calculations. So now we can move on to the next step where we're going to evaluate if the value in C18 is less than 5, then take that value and square it. So this little caret symbol, so I'm taking the value from C18, which is highlighted in blue here. This little caret symbol means it's going to calculate to that exponent, which would be 2. So we're just squaring that value. So in this particular case, since C18 is not less than 5, it's actually equal to 5, it evaluates to false, which what we've done here is place a 0 for false. But if I were to change this to 4, you can see what happens. It gives me 4 squared. And the same thing would happen if I wanted to change it to 3, because now this value is less than 5. And so what we've done in this case, we've actually replaced the value of true with a calculation. So I'm trying to build as we go along, as you can see how that can work. You can not only use calculations and things like that in your logical test, but you can use those to return a value from a calculation on your value of true or value of false. In this next example, we've got if C19 is less than or equals to 5, we want to square that value by, or not square that value, we want to make that value to its same power. So if in this case, it's value 1. So 1 to the first power is 1. But if I were to change this, 2 to the second power is 4, right? 2 times 2. And then I can change it to 3. And then 3 times 3 is 9, times 3 is 27, and so on. But if I go to 5, it's still calculating because now we have a less than or equals. But if I go to 6, it's going to return the value of false, which is a space. So I hope you guys are starting to see that. I know I'm going through a lot of examples pretty quick here. Just kind of wanted to get you started, and then we'll do another kind of a practical example. So I've got a couple more here that are a little more complex. So the logical test is actually a calculation evaluating whether that's greater than 10. So again, we're using a cell reference, which is C20. So is C20 plus C20 or 5 plus 5 greater than 10? We know it's not, so that should bring us back to value of false, which we've placed in here a string that says less than or equal to 10, and that's what we get. And if I were to change that to 4, we should get the value if true, and if I've done my math wrong, or greater than 10, my fault. Should be a 6. I'm going the wrong way. So you can see how now it brings back the value of true, which was the string value we placed in here greater than 10. And then here, we've gotten a little more complicated. If you don't know what the ln function is, it's no big deal. All it does is return the length of the value that's in that cell reference, C21. So that's basically going to return a value of 3, since there's 3 digits. So this is basically saying if the length of C21, which we know is 3 in this case, is less than 5, return that value in C21. Otherwise, return a blank value. So if we were to do this and make it the length of 5, it now turns into a blank. So just several kind of different examples using different values for the different arguments. You can kind of see how there's just a lot of possibilities, and it can actually get pretty complex, which if it applies to your task or your needs, you can see how powerful that can be, I hope. So let's move on to an example here. So let's say you work at the library or something. So you're trying to keep track of due dates. And so what we've done here is we've got a column with due dates, books or whatever somebody's checked out. And then we've got today. I've just used the today function to give us today's date. And so what we're going to do is we're going to evaluate whether today's date is greater than, or actually in this case, if the due date is less than today's date, we want it to place the value overdue in this column so that we know we can quickly evaluate all of our data here and pick out the ones that are overdue. So let's take a look at this. We'll do equals if, and once I place the if and it's highlighted here, I can go ahead and hit tab and it will open that parentheses for me. So I do that a lot. It's kind of a habit of mine. You should probably get in a habit of that too, because it's much easier than finding your parentheses and holding the shift and pressing the correct button. So anyway, if, and then hit your tab, and then now it gives you your syntax. So it gives you a little bit of help here. So the first argument is our logical test. So what we want to do is we want to evaluate whether cell B4, and I can go ahead while that's blinking, while the cursor is blinking, I can actually click on the cell if I want to use that cell reference. And I want to evaluate whether that is less than today. And I'm going to use the today formula or function just to show you that you can do that. And then we'll do a different method. So it's just today, open and close parentheses. And so when I hit my comma, you can see now that the value of true argument help here is in bold. So that means that's where you're at. That's Excel telling you this is the argument at which you're at. So if that is true, if B4, if that date is less than today, we want to return the value overdue. That'll be our value of true. If not, if it's false, we'll go ahead and leave it blank. We don't need to look at it. We're not going to worry about it because the due date hasn't passed yet. So I hit enter, and of course we see that overdue value in there. And in this column here, you can still view the formula, but see the results in this column. And all I need to do is, while this is highlighted, hover over this green square in the lower right-hand corner until my cursor becomes a plus. Left click and drag that down. And we can see here we've got 2 due dates that have already passed. So we do get that overdue. So it's just kind of a quick practical example of how you might use the if function. And then we could also do the same thing, but we're going to use we could have used cell references for the entire logical test. So we'll just click on B4. If that's less than C4, we'll also just do what we did in the previous example. And there you go. So it's just two different ways of doing the same thing. Obviously, since we already had today in this column, I mean, it just makes sense to use that cell reference. But if you didn't have that, you could have, if you didn't have this column, you still could have evaluated that, since you're looking at something that's revolving around due dates, and you just could have used that today function to give you today's exact date. So just a quick kind of practical example of how to use the if function. So let's move on to the and function. And so what the and function does is allows you to evaluate more than one logical test. So you can see the syntax here. It's just equals and then you have multiple arguments here that you can use. And I should have known this, but I cannot think off the top of my head what the limit is on the number of logical arguments that you can use in this. So forgive me, I don't have that detail for you. But just know that you can use several, and that's kind of the basis of this function. And so what the and does is it evaluates multiple logical tests denoted by the logical 1, logical 2, and 3, and so on. And they all have to be true in order to return a true. You don't have to place any true or false value within the function or within the formula. All you're doing is you're evaluating multiple logical tests, whether they're true or false, and it's just by default, as you can see here, as we look at and with just one logical test, it's basically the same as doing an if, but you don't have to place the true or false value in. We're going to evaluate whether 1 is greater than 0, and of course that's true. Then if you move on up to 2 arguments or 2 logical tests, you're going to evaluate if 1 is less than 0 and 0 is greater than 1, which we know both of those are wrong. So this was already false at the first logical test. But then the next example, we can see that the first logical test is evaluating whether 1 is greater than 0, but then it's also going to evaluate is 0 less than 1. We know both of those are true, so this evaluates to true, of course. And in this case, we've got 3 logical tests. If 4 is greater than 1, 3 is greater than 1, 2 is greater than 1. So the thing to take away from the and function is you can place multiple logical tests within this formula. They all have to evaluate to true in order to return a true value. If any one of those was not true, it's going to evaluate to false. So let's take a quick look here at, we'll kind of stick with our due date idea, but now we've got another data point here, which is the date the book was returned versus the due date. So we have due dates in this column, then we have if the item was returned, we're going to go ahead and have that date it was returned placed in here. So what we want to do is we're going to use our and function with the if function. We're going to mix that in. And in this case, we're going to check and we're going to evaluate if we're going to evaluate something based on the due date and something based on the date returned. So let's start our function here with the equals if tab. And so we're going to evaluate more than one logical test. And the way to do that in this case is to use the and function. So I'm going to go ahead and type and right inside for our first logical test, hit tab, and it will now open the parentheses for the arguments for my and function. So the first evaluation I want to make is B4 less than, like before, is it less than today? And so I'll type in that function. And not only do I want to evaluate whether B4 is less than today, I want to evaluate whether C4 is blank or not. because that's going to tell me whether there is a date returned. So I'm evaluating two different items here. So before I go any further, hopefully I can clarify this, because I'm feeling like I'm about as clear as mud on this one right now. But so what we're doing is, first of all, we want to know, has the due date already passed? And so we're evaluating that by the logical test, is B4 less than today? If the date is already passed, we'll know it is less than today. The next thing we want to know, is there a date returned value in the C column? And so we're using whether C4, that value is blank or not. And if it is blank, that means that book has not been returned. So I hope that clarifies a little bit before we move on. So now what I've done is I'm still, if you can see in my if function, I'm still within the logical test, but now because of the and, I'm allowing myself to evaluate two logical tests. And in this case, both of them have to evaluate to true for my if logical test to evaluate to true.
Hey Todd, sorry to interrupt. There's
No
a quick question. Chris Wheeler asked, when evaluating a cell, does the order of greater or less than matter? In the tutorial you had equals if,
Yes.
open parentheses, B4, less than, greater than. Yeah.
Yes, that's actually a good question, and I forgot to actually mention that. So I think what the question is, if I'm correct, is the order in which you would type the equals or the less than or greater than symbol. Yes, you need to type the greater than or equals. The greater than or less than symbol prior to the equals symbol. So the equals would always come second in those greater than or equals or less than or equals situations.
Well, that's good to know, actually. But specifically, he was asking. I think what he means is, does it matter whether you begin with, because you've began with less than and then followed by greater than? Does it matter which way those are if you have them both in there? So if B4 is less than or greater than, blank. Could it be written as greater than or less than?
No, in that case, yes, you do have, it does have to be less than and then greater than. And that essentially means not equals. That's the way to write or to type not equals. So yeah, it has to be the less than symbol, then the greater than symbol.
Brilliant. All right, perfect. Thanks a lot, Todd.
Okay. Yeah, I did. I think I thought of that as we were going along and forgot to mention that. So, but in that, well, that's in my PowerPoint. But yeah, that's definitely critical. And you'd probably run into errors and probably figure that out the hard way. But definitely in those cases where you're using the less than or greater than, or essentially what means not equals, it does need to be less than first, then the greater than. So back to the example here. So what we've got is our logical test, but our logical test is evaluating two different criteria at this point. And again, it's whether the date in B4 is less than today, and if the value in C4 is a blank. And so the value, if true, is going to be overdue, because if the date is already passed, but we have no return date, that means the book is still out and the due date has passed. So we want to type in overdue again for our value if true. And of course, if it's false, we'll just leave it blank because we don't need anything there. We'll just leave it. And so in this case, we don't have a date returned, but this book was due back on the 3rd. That date has passed, and we have no indication that anybody's returned it. So we know that is overdue. Now I'll fill this down, and what we should get for this row here, where the due date has passed, but there is a date returned, it should be blank. And of course it is, and you can see here what's going on. So this is a good example of how to mix in the AND function with an if formula to expand your logical test to cover two different criteria, or even beyond that. And then it can get pretty complex, as you can kind of see, but it can be very powerful too. So this is a case where both of those tests have to be true. Now we'll move on to the OR function. It's a great segue into the OR function, and it's almost exactly like the AND function, but basically it's saying all you have to do is evaluate one of these logicals in this function or in this formula to be true. So whereas the AND was testing to make sure all the logicals were true, in the OR function it's just testing to make sure at least one of those is true. So in this case, we have is 1 greater than 0 or 1 less than 0. Well, we know 1's not less than 0, but since 1 is greater than 0, this actually evaluates to true. So you can see the contrast there to the AND function. And in this case, 1, we know 1 is not less than 0, 0 is not greater than 1, so neither one of these is true, so it's going to return false. But then again, back here, 1 is greater than 0, and 0 is less than 1. Both of those are true, so of course it's going to return true. But again, the crux of this function is that all of the logicals don't have to be true. Just one of those has to be true for this to evaluate to true. So let's see how we can apply that. We can use that kind of in the same situation or the same scenario we were just in, just a different way of looking at how to come up with a formula that can give us the same results. So in this case, we're going to be using an if function, mixing in the OR function with our logical test to evaluate two different criteria. So instead of checking to see if B4 is less than today, what we'll do is we'll evaluate whether B4 is greater than today. And then whether C4 does not equal blank. So here's an example in action here of how to set up and how to type the order of operations in which to type your not equals to blank. So we'll close those parentheses, and that's our if logical test. And so we're going to put blank for a value of true, and then overdue, as our value of false. I feel like I've forgotten. I've missed a comma or a parentheses here. Yeah, something's all right. Oh, goodness. Forgot a very main, very imperative detail here. I didn't type my OR function. So, okay, so we've got if, and in our logical test for the if, we've used an OR function to evaluate two different details here. So, is B4, is that date in B4 greater than today or in the future? Or does C4 not have a return date? And if those are both the case, we don't want overdue. We want it to just return a blank. If neither one of those is the case, we want to place overdue, which would be our value of false for the if function. So again, just like in our AND example, the due date here has passed. There's no date return, and of course that means that book is overdue. So if we were to fill this down, we're going to get the same results we did with the AND function. But again, using the OR, we've used a function that is going to evaluate one or the other, and only one of these has to be true in order to return a blank. So if C4 doesn't equal a blank, it has a due date, or the due date has not yet passed, it's going to return a blank. Otherwise, it's going to show overdue. So I hope that's just, it kind of gives you a way of looking at how to use the OR function or the AND function in the same way, using kind of the same example, try to keep some continuity here. So Now we'll just move on to the if error function. So we're kind of changing speeds here a little bit. And so the if error function is still built on kind of that if idea, but it expands it out. So it's saying if your value, which is the first argument in the if error formula or function, if that value is an error, return this value. So you can actually place whatever value you want if this function or this formula is evaluating an error. And the best way to kind of show you an example of where I kind of apply this to is, maybe you have some calculations that result in dividing by 0 at times. And sometimes I've had, situations where that's just a part of it. I don't want to necessarily delete those formulas. I might have a spreadsheet that have formulas going all the way down thousands of rows. But I don't want this ugly divide by 0 error showing up in those columns. So I can use the if error formula to do something about that. So in this case, what we've done is we've divided 2 by the value in B12. So that's a 0. If that were a 1, it's not going to evaluate to an error. So just to think about maybe situations where you've had to deal with calculations that do have some errors, and you've looked at, I know we've all looked at spreadsheets where we've had errors all over the page, and I work with people that they have these errors, and I'm like, why don't you use if error to clear all that out? It just drives me crazy to look at all those errors. So we can use if error, and it's real simple. So you take that formula, that 2 divided by B12, which is the 0, that's your value, and then you just place in a value that you want to return if that is an error. In this case, I've settled on 0. So instead of you seeing that error, it's going to just return a 0 every time there is that error. Same in this case. So we've got a VLOOKUP. I've got this little VLOOKUP table over here, and it doesn't matter if you know how to use a VLOOKUP or not. That's not really relevant here. What is relevant though, in a VLOOKUP, sometimes you'll get this NA error if you're trying to look up a value that does not exist in your lookup table. So we're trying to look up the value orange, and in this case we've got all these other colors, but there's no orange that exists. So if that's the case, it's going to return this NA error. Well, if you don't want that error in your spreadsheet, you just use this if error function, and we can just take that you can see here we've got this VLOOKUP formula, but all you've got to do is surround that VLOOKUP formula here with this if error, and that VLOOKUP formula becomes your value. And then the value if error is up to you. So in this case, I've just decided, well, I'll just place a string in here that says it's unavailable. So if it's going to return that error that results from that value, that lookup value not being in the table, we'll just put unavailable. So it's not a real complicated formula, but it's still built on that logical idea that if this evaluates to an error, return this value. And it can be very helpful. For me, it's more of just a house cleaning thing. And again, this ref error, if something happens, this happens a lot of times when maybe you have a formula that uses maybe a value or a cell in a column that gets deleted. But if you just have things set up, I mean, this is going to show you an error if that happens, which is going to alert you to a problem. But especially if you had calculations in there, all of a sudden, if you had this column of 2,000 rows that had calculations and values in it, all of a sudden it's blank. If you've placed this if error function in there to return a blank, you've kind of alerted yourself that something's missing, something's wrong. So you can remove the error and it still kind of alerts you to a problem because it's going to be blank. So it's just kind of personal preference, but I did want to cover that because I use it a lot just because I don't, if you have these errors, say you have a spreadsheet or something you're sending over to a client or to coworkers or colleagues, it can just be really sloppy to see all those errors, and sometimes they're just unavoidable. In this case with the VLOOKUP, it's just the way it is, it's just not available. Or even with the divide by 0 error, sometimes you have formulas that are going to have zeros in in that denominator, and it doesn't mean you need to remove all the data. It still needs to be there, but you want a way that you can use a logical function to clean up all that data and make it look a lot nicer. So in this case, let's look at real quick. I'll try to keep moving on here. I know we're running out of time. So in this case, let's do a quick divide by. Say you've got a numerator and you've got a denominator you're going to divide by. And so you've got this value here. So no problem. You've got the calculation done. We can fill that down, but of course now you've got some where the denominators are 0, and it's kind of this is what I meant, but it's just kind of ugly. If you needed to send that over to somebody, I don't know about you, but for me, I don't want to send over something looking like that, because especially if it's someone who doesn't know the technical details of what you're doing, that might just create some anxiety. Hey, your spreadsheet's messed up, your formulas or your functions are messed up. So it's a chance for you to kind of control that and kind of avoid having to explain all that.
Hi, Todd, I've got a question.
Sure.
Can we place if error in the error result field itself instead of creating that in the next field?
Repeat that?
Can we place the if error in the error result field itself instead of creating that in the next field?
I'm not sure I follow. So
yeah, if Kamal, if you could potentially just clarify that a little bit further. Okay, John is saying yes, it's created in the next field here as an example. Can we? So I think that the answer is yes. But if you could just clarify further, Kamal, if you want your question answering, then we can make it as easy as possible for Todd to do that.
So maybe this isn't the direction I was headed, but that's okay. Let me do this. Let me type this and see if I get any results or any response from it. So I can evaluate the field that I just made the calculation in, and then if that's, I'll just blink by return if it's neighbor. So so I don't know if that's what the question intended. If I could evaluate the field in which the calculation was already done, or I could place the calculation within the error. You can do either. So I don't know. I hope that clarifies it. I'm not sure though.
Yeah, I think so. I think so.
But again, here, there's a bunch of blanks. If you wanted to just evaluate to 0, you can do that as well.
Yeah, just to quickly say thanks to Ben and to John, just for trying to help out. That I really appreciate that.
Yeah, so if I'm going to move on, but if you get some clarification on that, if that wasn't the clarification, I don't mind stopping.
I think that you were spot on. But of course, if anything else comes up, I'll just let you know.
Yeah, okay. Well, that's great. I mean, this is basically the same thing I was going to show, but I was just going to put the calculation itself as my value. But you can do either. It's interchangeable. Like all of these functions we've been looking at, you can either place in the literal calculation, formula, whatever, or you can refer to a cell reference that already has that calculation in it. So the only reason that you might want to do it with the calculation itself in here is that you don't have this extra column, but in a real world situation you could always hide this column and whatever. It's personal preference really more than anything else. So I just hope everybody kind of gets to see or a chance to see different ways of doing it. So whether it's a cell reference or the actual literal calculation, either will work. It's the same difference. So I'm going to get a little more complicated here, and what I think is a little more fun is moving on to the sum if, and it's one of these, one more of these functions that's built on the idea of the if, which basically performs a calculation, like for instance in this case a sum, based on a criteria. So it's not just a straight sum of all the values. If you wanted just to sum these test scores or whatever they are, that would be okay if that's what it called for. But maybe you want to take a look at, for instance, all the, you just want to sum the values that are greater than or equal to 90. So I'll look at this two different ways. So let's just start this way. So the sum if gives you, you have three arguments. So you have the range argument, then your second argument is the criteria, and then you have your sum range. And you'll notice here on the screen, the sum range is enclosed in square brackets. Again, that indicates that that's an optional argument. And the case in which this would be an optional argument is if, for instance, we just had this one column of scores. So if I wanted to evaluate this range of scores, and I wanted to sum all the scores that were greater than or equals to 90, that would be my criteria. So let me just show you that. So for our range, we'll select this entire range, and I'm going to go ahead and, yeah, I'll just leave it. I'll go ahead and lock that. So I'll hit my F4, which locks that range so that I can drag them down just to save time here in a little bit. And so when I hit my comma, it goes on to bold the criteria range. So the criteria is going to be, I'll just use the cell reference, which is greater than or equals to 90. And again, I want to reiterate here, based on the question we had earlier, that it must be the greater than symbol before the equal symbol. So that's the right way to do it. And then I can close these parentheses and then hit enter. And it's going to give me a sum of 288, and that's going to be the sum of all these scores that are 90 or greater. And so notice I was able to omit the sum range because it's irrelevant, because I'm basing the criteria on the range within that which I'm trying to sum. And I hope that that's probably as clear as mud, but I'm going to get to why that's relevant. So if I wanted to drag this down, you're going to see these are going to be greater sums. Well, forget this. This is going to confuse you. I don't know why I put that there. So what I'm doing is I want the sum of all scores greater than or equal to 90 here. In this case, the criteria is now all scores greater than or equal to 80. So it includes all the scores from 80 all the way up through whatever the highest score is, 98. In this case, this is from 70 all the way up. I don't want you to be confused to think that that's just all the scores from 70 to 80, all scores from 80 to 90, because it's not. So see the formula here. There's one range, it's the range of the scores, and then your criteria is based on a value within that range. Now in this case, we're going to use all the arguments. So we're going to have a condition, or we're going to have we're going to have a criteria range. It doesn't call it a criteria range in this formula. So let me just go ahead and start, and as I'm going along, I'll explain where we're going with this. So the first range is not the sum range in this case, because what I want to do is I want to evaluate and sum these score values based on the grade values in this column, in the grade column. And I can do that by selecting the grade column as my range, my first argument. And again, I'm going to lock that just to save time as I drag these down in a minute. And then now my criteria is going to be this value. So I've got grade values A, B, and C that I want to check against values in this grade column. And now the comma gets me to my sum range, which is the score column. So I'll lock that. So basically what we're doing now is I'm going to sum all the score values that are equivalent to a grade of A in the grade column. So now I've got three arguments, as you can see up here. But the first argument is now my criteria range, which is not getting summed. It couldn't get summed because it contains string values. And then the D10 is A, essentially A. So it's finding all of those rows where there's an A, and it's going to find that value in this score column, or B, and then sum those. So now we get here you can see it's the same value. But as I drag that down, now you see what we've done here. We've actually been able to eliminate any values that don't correspond to a grade of A or grade of C on this row. And likewise here, we've limited it to just score values that equate to a C in the grade column. So there's two different ways to use the sum if. If you just have one column and your criteria is going to be based on something within that column, you can omit the sum range argument. If you're using multiple columns or you're evaluating some criteria that's in a column that it's not within your sum range, you're going to use all three arguments. And I hope that makes sense, but it's a very, very powerful function. And again, it's just based on that same logic of where this criteria is true. So in this case, where in your range where it's true that it is the value of A, then it takes that value and it includes it in that sum formula. So I'm going to skip sum ifs real quick because I want to get to count if and show some examples with that, because I know not everybody has the most current version of Excel, and I want to kind of get to this first. So in this case, the count if is very similar to the sum if, but instead of summing the values, it's going to count the number of instances. And so this could be pretty valuable. You want to know how many grades were there in these test scores that were in A. So I'm going to use this, step it up here a little bit. So we'll start count if, tab, and then again, right here we have just a range argument and a criteria argument. So it's going to take this range here, and I'm going to lock that with F4, and then my criteria is going to be, is it greater than or equal to 90? And so now it's just going to count the number of scores within this range that are greater than or equal to 90. So we have a 97, a 93, and a 98. There are three of those. And if I drag this down, it's going to say there's 6 values that are greater than 80. Well, we knew there were 3 greater than 90, so how many are there within the range of 80 to 89? There's 1, there's an 85, an 87, an 82, 3. So it's counting the number of instances. So, say you had your sum if values for your test scores and you wanted to do like an average of those, the count if could calculate that for you because it can count the number of those within a range. And this is just a range of, what is this, 10 rows, but you can just imagine if you wanted to translate this to having a worksheet where you had hundreds, if not thousands of rows. This can be extremely powerful, extremely valuable. So the next thing I wanted to look at, and I know we're running down to the wire here, one of the greatest things about the if function and logical functions in general, but especially the if function, is that you can really leverage its power by using the if function or other logical functions in your value if true or value if false. And what that basically means, especially with the if, is you're nesting multiple if functions within other if functions. And I know this looks like a bit of a reading chart, so let me kind of zoom. Hopefully I can zoom in here real quick and just look at this. I just want you guys to kind of see this. I'm probably not going to have enough time to work through this, and it's pretty complicated. But let's say you had a situation where you've got, just did a project for a client that it included creating some calculations for commission rates for real estate agents. So there were different tiers, and so like for instance here we have a tier that if someone gets a gross commission income of less than almost $18,700, their commission rate is 30%. And as they reach these different thresholds, it breaks up to a greater commission rate. So the way to evaluate this, since we've got 5 different thresholds, is we've nested if functions here about 5 different times. And so I know, I apologize, I know this is like a reading chart, but so the first if evaluation is a C4, which is the gross commission income, is less than H4, which if I go back over here, that's our threshold dollar amounts, right? So that first threshold is being evaluated. And so we're evaluating whether Sarah's gross commission income of just over $45,000 is less than, what was it, 18,699. So in this case, the first evaluation is 45,000 and change less than 18,000, whatever. The value, if true, would be I4, which is the commission rate for that tier. But if it's not, which we know 45,000 is not less than 18 grand, we put in the next if function. And so the next one, which is our value of false, so instead of being done with some value of false, we're going to keep evaluating. And we do that by nesting another if function that evaluates that same gross commission income for Sarah versus the next tier, which was 37,398. And so see here, we've got this if function, logical test, value if true would be that commission rate. Well, we know this still isn't true, so the next, we know it's false for this for this if function. So now we've nested the next if function in this value of false, and we'll continue to evaluate. We'll continue to sort of terrace that evaluation until we get to the last one. And this is a great way to evaluate these dollar amounts versus this chart here and return the correct commission rate according to this value. It's, again, it's complicated and it gets pretty crazy, and you have to remember to keep up with your parentheses because it starts to get pretty crowded there. But you can nest up to, oh wait, it escapes me now. It's something like, I want to say the limit is in around 60 of these. I could be wrong. I feel like I am. However, the limitations, I mean, obviously this is extremely powerful, but you're going to reach your, you're going to reach your limits on how this can be effective, and, not prone to error. So it's an extremely powerful way to do things, a way to use the if function. But if you've got, Excel 2016 or Office 365, the newest versions, they've got, Microsoft has finally come out with what's called the ifs function, and it's kind of their next best answer to the nested if. And so basically, you've got a chance here now to, instead of nesting more ifs, you can take a logical test, and you can see here the syntax. You got logical test 1, value of true 1. Logical test 2, value of true 2. And so basically you're doing the same thing, but you can see here it's a lot less, I guess, a lot less complicated looking, a lot less of an eye chart. It still is a bit of an eye chart, but you don't have to keep up with multiple parentheses. And so when you get down to the last evaluation, like here, we're testing 5 different thresholds. Logical test 5, value if true 5, and then you're done. There's no value of false in this situation. So eventually you're going to evaluate to some true level, and the maximum is going to be this 50%. So I know I kind of explained that very quickly and very condensed, but at least you're aware if you are using Excel 2016 or Office 365, the ifs function is available. If you go back and you learn how to use nested if functions, this ifs function is going to mean a lot more to you. So I know I kind of rushed through the last part of that. I just kind of want to cover things and give you guys some exposure to that. But I think I've used up at least my allotted time, maybe a little bit more. So I'm going to kick it back to James real quick.
Hi, Todd. Yeah, it's past, so we've just gone through the hour, and we have a question here from Taiwo, which is it possible to use a color row to represent the true or false?
A color row? Well, yes, you can actually use this well, I say yes if you use conditional formatting, because with conditional formatting, you can use formulas to make evaluations. So yes, it is possible. I don't know. There is a possibility you could. I don't know if there's a formulary way to use to change the fill color. I don't know that I've ever done that, but that's an interesting question. But I do know that yes, with conditional formatting, you can manipulate that because there are options in the conditional formatting where you can use a formula to set those rules.
Right. Uh, Ivan or Ivan also was asking. This sounds quite meta. Please, can you explain how to create a formula to show a formula?
Well, I don't know if you're talking about like in this case, this may not be exactly what you're asking. There's actually a function in Excel 2016 and I believe Microsoft 365 as well called formula text, which you can type in, and that's what I've been using here to show these formulas. A formula to return a formula, it would just be a string. So if you wanted to say this was, let me go back to the if example, say, well, I'll just use this real quick. So the only way to return a formula would be to make it a string. It wouldn't actually, unless you're talking about using a formula as that value if true. You can do it both ways. I'm not sure I understand if they mean a formula to show it literally as a result or actually make a calculation.
I think that Ivan will probably clarify because he's quite quick on the keyboard. He's talking about literally.
Like, okay, so literally as in showing a formula itself,
Yeah.
the text, it would just be a string. So, I mean, if you wanted to do if, whatever, oh gosh, if you look up, I mean, it'd be something like that if that's what he means.
Yeah, I think so. He's not said anything yet. Yeah. Anyway, moving on to accessibility and that kind of thing for this webinar. If you have any questions that you'd like asking but you don't get in within the allotted time, you can send an email to info@webinarsteam.com and we'll do our best to answer those. We'll also be uploading the recording of Todd's webinar and we'll send that out to everybody who registered, hopefully within the next 48 hours. So that I know there was somebody earlier on, so somebody had, I think it was Mike, had some issues with his connection, so the sound wasn't coming through very well. If anybody had any of those issues or would simply like to revisit the recording, we'll send you a link to that as soon as we possibly can. Thanks a lot, Todd, for that, because I thought it was fantastic. Really, really great for me. I have to use a lot of functions at work, and actually, I'm not as good as most of the other people here at work, and it was really clear to me. I hope everybody else learned as much as I have. And that's one of the real perks of doing these webinars is I get to learn something every week. So I guess thanks to Todd.
You're always welcome.
And yeah,
it's my pleasure.
It's 25 to here, and well, it's at 25 to everywhere, but nobody seems to be asking any more questions, and we're 5 minutes over, so I think we'll call it a day there. So to everybody who's here, have a nice week, and thank you very much. We'll hopefully see you next week. Bye bye.